Okay, thank you for coming. So today we'll be talking about the topic here, MikroTik. Um, topic about controlling access between devices in the same layer 2 segment. My name is Achmad Mardiansyah, and then I'm from GLC Networks Indonesia. Uh, okay, I need to update the agenda. So the agenda will be talking about the um, basic of networking. Oh. Yeah, so the agenda will be talking about the layer 2, how to control access in layer 2. Oops. Yeah, so what is, for those who are new, we are GLC, we are Lintas Cakrawala, we are based in Bandung. Our areas are training and IT consulting. We are doing MikroTik, Ubiquity, Linux, and then programming. My name is Ahmad Mardiansyah. I'm based in Bandung as well. I do teaching for living and do consulting, and then develop some software for usually for ISP. For more details about myself, you can connect to my LinkedIn account, LinkedIn page. So our past experience, most likely we are we are doing ISP work, like integration, commissioning, and then optimization, setup routing, and then so on and so forth. Yeah, most likely related to ISP. Oops. Yeah, about the webinar itself, we started webinars in 2010, and then you are um, yeah uh, um, um, you are very welcome. Yeah, if you want to be a presenter here, I mean, you can share anything. Yeah, anything. Anything you like. Based on your experience. So mostly the topics are related to what is it? Networking, programming, and then system administration. Thank you very much for coming. I can see some of you are already coming here. Some are Indonesian, some are not. Okay, thank you very much for coming. And then, for understanding these materials, so we encourage you to, we assume, not encourage. Yeah, we encourage you to understand, yes, and then of course we assume you already know some of the topics here. For example, networking, and then MikroTik router OS, especially with the fundamentals how the layer 2 works. Okay, so let's do a review. Okay, so we already know we have a 7 OC layer, and then with the communication we need to do encapsulation from top layer to the bottom layer, and then we send the data to the respective partner that is located far away over there. So as you can see, we can see there is a big overhead of encapsulation process. Yeah, more technology means usually more encapsulation, more header. Yeah, so this is what you send on your WhatsApp, for example, but this is what you actually send in your network. Yeah, so from here to here. Yeah, so there is a big overhead. So yeah, that's how communication works. And then router and routing. Router is the device, routing is the process for finding path in layer 3. The way we do communication is we set up like this. We develop a physical topology. So this device connect to this device, from this device connect to that device. So actually all computer in this internet are connected to each other. Okay, so there is no any computer, if you say that you're connected to the internet and then you're completely isolated now. So if you are completely isolated and then you cannot access the internet, right? Yeah, um, so there must be a physical connection from you and then your partner in terms of networking. Okay, physical connectivity either through a tangible media like copper wire, fiber optics, the things that you can see, or it can be not based on wired, like wireless. Okay? You can use uh, electromagnetic wave or a uh, light-based communication. Okay, so after we set up a physical topology, physical connectivity, we develop a layer 3 mapping. Yeah, so here we don't have, we will not see a physical connection anymore. So what we see is just a collection of a network. Yeah, so this network connected to that network. Yeah, and then this one is called the logical topology. Okay. And then here we can see the router that is connecting network segment. And then the way router work is using the routing tables. So packet coming and then check the routing tables and then forward to the other interface. Okay, so this is an example. And then on MikroTik, so this is the place where the routing table lookup happens. So packet coming from here. So we have a chain and then we have a routing decision. Either is input or forward, and then forward to post routing, and then packet leave the interface. Okay, coming here, output here. Okay, also if the process is coming from the router itself, it's called local process. And then if, for example, if you log into your MikroTik and then you want to ping outside, then it's called local process output. Okay, so sorry, so it's gonna be like this. Yeah. Okay, so that's how the uh, packet processing works on MikroTik, and then so we're talking about layer 2, but this is just for information, just refreshing your understanding about how how routing works, especially with how the administrative distance affect your routing table. Yeah. Okay, so this is administrative distance depends on the routing protocols you're using. Okay, and then the way we manage the routing is we can set up static routing or dynamic routing, and then you need to know that the routing is asymmetric. Okay, there is no guarantee that incoming path is similar to outgoing path. Okay, so after that, because here we are talking about controlling access, you like it or not, then we need to talk about the firewall concept here. Oh, okay. So why do this one different? Okay. Too many slides. I need to delete. Okay, so this is Critic Firewall. Um, yeah, so we have actually four main functions. Filter. Actually, the main function are three, but the chain here we have four. Uh, so we have a filter for controlling network access, modify header or marking packets. Okay, but here's also another one which is row, and then usually it's used to filter traffic without um, without what is it, without having more processing on CPU. Okay, so that's the difference on different type of MikroTik, different chain. Actually, it's a technical term. Is a chain. We have chain filter, NAT, and Mangle. Okay, and then how firewall works is you define a matchers, and then Here are the matchers, and then here's the action. Okay, so all of them are action. So, and then you have lots of options for matchers. So based on the address, IP address, based on the protocol, we don't have peer-to-peer anymore. Yeah, based on input interface, based on interface list, based on the marking, based on the connection, so on and so forth. So you have lots of options for to define a firewall, and then firewall is created, executed sequentially. And then here's an example of how packet is processing. Okay, as I said, packets coming from here. Okay, go to pre-routing, routing decision, either input or forward, and then go to post-routing, and then quit. So if you zoom here, and then here's the sub-process of the pre-routing. If you zoom forward, it's going to be like this, and then here are the process. Okay. Yeah, we're not talking about those process in the details. So yeah, we can talk about it later. Yeah. So previously we saw that we have 1, 2, 3 main chain on a firewall, and here they are. Okay, so here's the place. Here are the places where you can put your your um, your role, firewall roles. Okay. Uh, Watercolor is different here. So mangles available in all chains. Okay. So here they are. Filter is only available on input, forward, and output. Oh, looks different here. Yeah, I need to update the colors to make it easier to understand. Perhaps this one. Oops. Okay, I'll do that later. Oh yeah, now it's better. Yeah. Okay, I have updated this slide. Sorry. Yeah. So we need to know the difference between forward and input. So input is when you access the router directly. So you're accessing the IP address of the router. For example, if you ping the router, you log into Winbox, okay, of the router. You're logging to your router through Winbox, sorry. But if you ping Google and accessing your other server out there, and then you'll be using forward. Okay. Remember the difference between forward and input. All right. So next is okay. So since version 6, MikroTik pulled all together in one diagram, but there will be explanation, more details in every diagram. Okay, so here they are. So it's quite complex, but it is easier to understand. So packets coming from here, checking the interface, whether the interface is bridgeport or not. If not, and then goes here, checking is it is there any MPLS traffic? If it's no, goes to here. So is it IPv4, IPv6? If yes, and then goes here. Okay. And then either you check input. So here we are doing routing decision. Okay. By by after the routing decision, and then we have input or forward. Okay, so let's say if we ping Google, and then we will go to forward here, and then of course there will be an output. Okay, uh, checking if MPLS traffic presents. No. Check output interface is bridge or not. If no, goes here. Um, and then encapsulate if if uh, there is no encapsulation. Yeah, for example, if you have IPsec and then there is no encapsulation, goes to interface HTTP, goes to physical interface, and then going out. So this is incoming, and then in, and this is out. Okay, that's how you do the process of yeah, packet flow. Yeah. Next, we talk about how layer 2 technology works, like for example, Ethernet. So this is Ethernet specs. Okay, so why do people choose Ethernet? Because it's cheaper, and then this is one of the best Ethernet interface. Why? Because it's got four interface, and then each interface is handled by one chipset. So that's yeah, that's why it makes the interface here is quite expensive, because more processing on that. Some cheaper micro, some not some cheaper micro, some cheaper Ethernet. Usually they have a single chip for all of them. Okay. All right. So how Ethernet works is by CSMA/CD. So we have in the middle, we have a concentrator, and then all of them connected to this concentrator. Usually it's hub. So when you send something, the others will see what you are sending. Okay. So this is the early Ethernet development, Ethernet technology. So you can people can see each other. Okay. And then this one brings a problem also, which is collision. So for example, if host A and host B are sending at the same time, there will be a collision. So yeah, each of them will do the random waiting and then send the packets to the network. So this is how it looks like. Okay, how Ethernet works. The the thing for Ethernet work is CSMA CD. It's different to Wi-Fi, where you are using CSMA CA, so collision avoidance. So there is no collision actually in Wi-Fi, because we have a mechanism to avoid the collision. Also here with the Ethernet, so Ethernet is layer 2 technology, and then in order to have a end-to-end communication, we have IP. So there must be a bridge between IP and layer 2, which is the Ethernet. So here we are using ARP request. So for example, if I want, so if this PC wants to talk to PC number 5 here, okay, so first PC number 1 needs to know the MAC address of PC number 5 here, from here to here, right? So it sends our request, and then from PC number 5 here will reply its own MAC address, okay? So that's how it works. Okay, so this is Ethernet evolution, started from coaxial cable, and then 10 Mbps, 100 Mbps, based on copper wire, based on higher speed of copper wire, Cat 6, Cat 7, and then based on fiber optic. Now, uh, some Ethernet interface can pump up to 100 gigabit per second, and then it keeps counting. Okay, so as you can see here, uh, for collision domain, several Ethernet issue. Yeah, and then issue number one is collision domain. Is the consequence of using CSMACD. So host A send, host B send at the same time. You have a collision, and then we have a collision domain here. Is the place where a collision happens. Yeah. So some ideas are, so instead of using hub, hub is a uh, what is it? Is a device where you send to one port and then the hub will send to the other port right away. So hub is you can say is a dump is a dump a device. Yeah. Okay. So that's hub. Uh, yeah. Or you can use a switch device. Okay. So hub is very hard to find now because most of the device now is switch. Okay. So the way switch does is checking the incoming, checking the destination MAC address, okay, and then only so we can call it micro segmentation, yeah. So switch only forward the packet or the frame into particular destination port, not all ports. So this is the difference. Okay. So that's why if you are using switch, you can say it's like splitting collision domain. Okay. So if you have four ports and then you have four collision domain, so which is uh, really improve the performance. Yeah. So I use not MikroTik. I set up MikroTik for the first time in 1999, 2000, and then we're still using Hub at that time. And then if you have lots of device connected, and then the performance is very, very slow. Next issue is a broadcast domain. Is the place where the broadcast happens. So previously collision domain, here is broadcast domain. Okay, you should know the difference. Yeah, and then we can split the broadcast domain by using a router. Okay, other problem here is I think this is from dev2.com. Yeah. So looping. Yeah. So for example, you have a switch here and another switch here, another switch here. Yeah. And then uh, in the beginning there is a broadcast frame. So broadcast send here, also send here, and same frame also send here and there. And then you have lots of frame keep going in the network on the switch, and that make the CPU higher. And then after CPU is higher up to 100%, and then usually it stops working. Okay, it resets and it reboots automatically, and then suddenly the traffic is good again. Yeah, and after that another another problem happens. Yeah, so the frame will be forwarded to a previous crash switch, and then looping happens again, and then suddenly it works again. So that's a sign, that's a symptom you have a layer 2 issue. Okay, if you see your network, if you are experiencing issue like that, uh, for example, it's very slow, and then after that, oh, the packet, the network is good again. So suddenly ping is the connectivity is good, but after that it's slow again, and then um, it after that after a while the network normal, and then problem, and then normal, so it keeps going like that. Usually you have layer 2 issue. Okay, so now let's control the access between devices. Yeah. So as you can see, if we have a network like this, and then we want to send packets or frame from here to here. Yeah. So from here to here. So what will happen? So first, router is not involved. Okay. So from here to here, we just only have a direct connectivity between devices. So from here to here. Okay, so direct connection. So nothing involved. Okay. So it's direct communication. And then traditional switch only check the layer 2 header. Yeah. So what's the destination MAC? Oh, okay. So it's the destination MAC address is here, and then I will set up a circuit. Okay. You know, in electronics we have circuit, right? So we have like a circuit created when you want to access a particular MAC address. So the switch is quite smart to understand the destination of your MAC address. What if the switch do not know the destination MAC address? So yeah, usually switch will send to everybody, and then hopefully by learning the reply, yeah, and then switch will learn the MAC address. So the way switch learn the MAC address is by checking the source MAC address, okay, of every traffic that it's handled. And then yeah, as a standard, as we are using Ethernet, we are using our protocol, address resolution protocol. Okay, so that's how the layer 2 segment works. Yeah. So how to control that? So I want to control here to here. I want to block the connectivity. How can you do that? Well, with traditional switch, you cannot do that. Yeah. But with MikroTik switch, yes, you can do that. How to do that? Well, if you buy a switch, MikroTik switch, well, actually this is a router. Well, router can be turned into switch. Yeah. So you create a bridge local, you put all ports into a bridge local. So this is the bridge. Okay, and then all the ports are here. Put all of the ports are in the bridge. Okay. And then after that, you activate IP firewall in the bridge here. Okay, so it means that all traffic in the bridge will be inspected by firewall. So it means that you can control from here to here because the packet goes to the switch into a bridge. From bridge, you do the IP firewall processing, and after that, if packet is allowed, and then packet will be forwarded to destination. So as simple as that. Okay. So what if the switch is not MikroTik because yeah, because you already have your own switch, right? So how can you do that? Yeah. So MikroTik introduced a feature called local proxy ARP. Yeah. So this is you, and then this is your device. Okay. So with the traditional layer 2 connectivity, it's gonna be like this. Okay. So what MikroTik can do is, let me change my color, is by activating the local proxy ARP here on particular Ethernet here. Okay, this is Ethernet number 2. You activate the local proxy ARP. Okay, So what happens when somebody sending to the other device in the same network? Okay, so what it does is, so when a device send a package, send frame or packets. So first it needs to um, send an ARP request. Okay, so we have an ARP request here. So that means all ARP requests will be handled by MikroTik here. Okay. Okay, so router will reply all ARP. Okay, so it means that we are expecting that all traffic will go to the router. Yeah, so it means like router is intercepting the traffic. Is it necessary in layer 2? No, it's not, because the router is layer 3 network. If you want to send packets to the different segment, and then you have to go through router. Okay, but here we are talking about connectivity or communication in the same network. Okay, in the same layer 2 network, which is not involved router. Yeah. Okay, but here our case is we want to control the connectivity between device in the same network and the same layer 2 network. So we activate this one. Okay. So how about the traffic? So the traffic goes here. Okay. Why it goes to the MikroTik? Because MikroTik will reply or our request. Okay. So after this, and then package goes here, and then finish. So because the package goes to MikroTik, you can add firewall rule over there. Okay. And then, yeah, the firewall rules needs to be on forward. Okay, on forward. So I forgot to put here. Yeah, so as simple as that. Anything else? Okay, so I think this is very easy. Yeah. On version 6, it works okay. Yeah, in the network, but for version 7, perhaps we need to adjust uh, some settings. Yeah, yeah, but it works. Yeah. So you can try at home, and then yeah, you can see the difference. Okay, so that's the ingredients how you do control uh, layer 2 connectivity, layer 2 communication. Okay, internal layer 2 communication, internal layer 2 segment. Sorry, yeah, I was thinking to find a appropriate word for explaining my idea. Okay, so we have two ways to do that. First is by using MikroTik switch, and then by using MikroTik router. Which one is preferred way? Number one here, by using MikroTik, because you are really controlling the 100% of the traffic. Yeah, because you can control up to the port itself. Yeah, for example, there is a why do we need to control layer 2 communication? Yeah, what's the motivation? First is sometimes there is a PC here that is infected by malware, and then this PC wants to send something to other clients. They're trying to infect other clients. So for this one, we need to control host to host communication. Okay, between inside layer 2 segment. Yeah. So yeah. So we need to control communication between hosts in the same segment. Yeah. So that's the motivation, because guys, if you are working in an office where 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 lots of many people are there, and then they bring their own device. So most likely one of them are infected by virus or malware, and then because they connect, and then the malware, the user do not know what is happening in their computer. So that's why when they log into the network, usually the network is very, very slow. And then we as a network engineer needs to find out why is it happening. Yeah. So yeah, again, for me, I would prefer this way. Yeah. You can use MikroTik switch. You put MikroTik switch on your network, and then you can fully control what is happening in your network. Yeah. So I prefer to use this way. Well, I think that's all. Yeah, I think it's already clear. We don't have to do practice. And then if you're interested, you can just come to our training. Yeah, this is end of slide. Feedback is available there. For further events, check our website, or also our Facebook page. A slide will be available on Slideshare. And if you want to join Discord, yes, it's available in Bahasa Indonesia, and recording is available on YouTube. Well, I think that's all. Thank you very much for coming, and then see you in the next webinar. Okay, goodbye. Have a nice day.